Good afternoon. It's a pleasure to be here today. I'll talk about blockchain in kind of three different ways. Number one is what it kind of means from a general purpose from the way I've been seeing it. Number two, a first use case that got us and my team working on this 3 years ago. And then finally, a solution to one of the problems that we had been facing when we were working on the use case. So I believe that blockchain is a general purpose technology. And a general purpose technology is very special because they are these rare instances in human history where a special type of technology comes onto the fore and helps drive innovation for the next 30 years. General purpose technologies were defined in 2005 by a scientist in Canada, and there are only about 30 of them. And what they do is they intermingle with other technologies, and they create new waves of innovation, new S-curves of products that allow for human society to be propelled forward. And so one general purpose technology is electricity, another one is the internet. And blockchain is particularly special because it allows the digitization of value. And it's something that we actually didn't really see coming. We knew about neuroscience, we knew about biotech, we knew about general energy systems that are coming through AI. Blockchain was something that we didn't know we had. And it came together because of Satoshi Nakamoto. He put together several components that now is going to drive the next wave of digitization for the next 30 years. And it's going to weave itself into the fabric of our society, and it's going to be much, much bigger than the internet has been. And if you think about since the late 80s and early 90s, what has happened in 30 years, it's been transformational. And blockchains is going to do more. If the internet drove the digitization of information, made it useful for us to digitize all this stuff that was on paper and in books, put it onto the internet so that people can share it, they could use it, what happens is that blockchain allows for digitization of value. The internet allowed for people to share their information. It spawned billion-dollar companies. It gave voice, as we've seen recently here in the UK and in the US, a voice to the powerless, but it also connected the powerful and made them stronger. But one of the challenges of the internet is that it is a copy machine. Once you put something onto the internet, you've lost control. And so what blockchain does is it allows you, in a sense, to take back control, to make it so that whatever asset you put into an open network, you still have control over. And the Tapscotts wrote a very good book about this. They said the Internet of Everything needs a ledger of everything. It's a truly open, distributed platform that fundamentally changes what we can do online. Call it the worldwide ledger. And what it does is it allows for the digitization of assets, whether they're tickets, tokens, securities, credit, currency, any of those things that they're currently on somebody's database, right? Whether they're at a casino or they're in a bank, these assets are in somebody's database. And what blockchain allows is that those assets live on the network and nobody owns them. It also allows for sharing of data across multiple databases, let's just say, into one common data store. And when you can do that, you can have much better efficiency of back office processes. You can identify across multiple players on a supply chain where there are bottlenecks. And you can run AI, ML, and data analytics on top of that to get insights and refine risk models. And it unlocks data lakes and big data tools. And finally, it allows for asset sovereignty. And this is something very, very powerful because we no longer need the third party in the middle. We can own our own health data. We can own our social graph, our private data, our financial assets, our cryptocurrencies, our tickets, and everything, and transfer them at will without anybody giving us permission. Once an asset is on a blockchain, it lives on the blockchain, and you can't stop it. And my claim is that blockchain technology is going to affect 100 trillion in value within 20 years. And so that's kind of the general perspective of what I've kind of come to learn over the last 3 years in this space. How did we get here? We started out with this idea of a scribe. What happens if you could put all intellectual property on the blockchain? because, in 2005, an economist in Britain took the land of Britain and said, okay, if the value of Britain is this much from a land perspective, what's the value of all the world? And the number he came up with, 50 trillion. Another economist in the States used the intellectual property in America and calculated how much that was worth in America, and it came out to 25 trillion for the world. If you think about from 2005 to 2016, all creation is really digital now. It's native digital. In that sense, you could say all assets are now digital. And so what happens if you can unlock that? What happens if you can actually make it so that the intellectual property or the assets that you create are yours to transfer? And what we saw was, and you all know this, the internet is a bazaar. If you want an image for a presentation, what you do, you go to Google, you search for an image, let's say a bazaar image, and then you right-click it, and you copy, you download it. Why? Because it's easy, and you have no way of finding out who owns it. How do you find the owner of this? And what we saw was that we could try to be the Google meets iTunes, where you could register intellectual property around the world. There would be a discovery mechanism for people to find out who owns this, and so when you did the Google search, you right-click, you could license it. That was the idea. But we came up against a major problem February last year when we were starting to work on this, in that blockchains don't scale. They don't have very good throughput. The latency is way too slow. Capacity is minimal. Performance gets worse as you add participants. You can't really have a richness of defining the assets and querying it. And finally, the tech stack is extremely novel. It's very exotic, and it's hard to work with. And so that forced us to ask some questions. What is a blockchain? Is it the sum of its parts? And Ken touched about this, right? At the core, blockchain is nothing more than a database, a way to come to a consensus, an agreement on whether or not a transaction is and should be there. And finally, encryption and cryptography, which allows that whole network and each transaction to be secured. And then we asked the question, well, fundamentally, what is a blockchain? What features does it bring? And the three ones that we came up with so that we could think about this in a way that allowed us to scale up a blockchain so that we could use it for intellectual property was it's decentralized. Everybody shares it. Nobody controls it. It's immutable in that you can trust it. It's transparent. And finally, asset autonomy. Assets live on a network. And we saw that as a pragmatic definition to start to say, if we're going to make blockchains work, because currently, this was a year and a half ago, they are unsuitable, that is what we start with. And so what we had seen was, we'd seen that everybody else, there were starting to be people who were working on proofs of concepts that were looking at scaling up Bitcoin. Looking at Bitcoin, forking it, and seeing how they could tweak it, take out different things, add in different things to make it scale up. So that was one approach. And we thought, that doesn't work, because my co-founder came out and did his PhD on scaling up machine learning algorithms. And what he learned was that you cannot scale up an existing algorithm. You have to actually define the inputs and the outputs, is what we just did, and throw away the algorithm and then start again and just model the inputs and the outputs. And so what we said was, what happens if we blockchainify big data? Instead of trying to make blockchain scale from where it came from, where Satoshi started from, but actually look in the world and see where is somewhere that already scales massively, and can we put blockchain characteristics on top of that? Because if we define the characteristics that are important properly, then we can create a blockchain where we redefine it. And we looked at big data databases, NoSQL distributed databases built on centuries of work, person centuries of work, where they've already scaled it, solved the performance, and is in enterprise already. And so we built it. We let a scribe pass because we saw that this was a more fundamental problem to solve. And what we came up with was BigchainDB. It essentially is a database that looks, acts, and feels like a large-scale database. It wraps existing databases. But what it does is it has throughput of the hundreds of thousands of transactions a second, probably even millions. Latency is sub-second. Huge capacity. The performance actually increases as we add nodes. You can define assets in any way you want and query it. So not only do you have assets in a database, but you actually can work with it, which is actually fundamental to making blockchains usable for enterprise. And finally, it's something that enterprise already uses. And we built blockchain characteristics on top of existing technology. And it's complementary to all the other blockchain technologies, which is also an added benefit. And it works a lot like the domain name system from a conceptual perspective on how we thought it would work. We have two of the kind of core architects of the modern domain name system working with us and advising us. And what you have is you have this core database, and then on top of that, the core database does one level of consensus, which is just ordering transactions. That's what gives it the scale for most databases. And then what you do is you make it so that each computer, each network node comes to a consensus on how do you validate it. And with this two-level consensus, that was the thing that unlocked BigchainDB and made it so that we could have the best of two worlds. We could have the qualities of what Bitcoin and blockchain offers, immutability, data, decentralized control, asset autonomy. But we also had the throughput, latency, capacity, and the performance requirements that we need. And that's BigchainDB. And that allows for massive scalability, the immutability of the data. You can have flexibility to define your security and privacy. You have an architecture that inherits the qualities of the underlying database substrate, the database like MongoDB or RethinkDB or what have you. And finally, what we also built in was business logic automation. It's one step back from smart contracts because it's much more verifiable. Most of our team comes from an AI ML background, but circuit design as well. And that is something that allows for business logic to be modeled in a very, very safe way. So what we also saw was we built this core technology, but we didn't have a network. So we built this BigchainDB. But one of the advantages of Bitcoin or Ethereum or even now Zcash is that they have a network that makes it really easy to, I guess, join. Maybe not work with, but join. And so what we saw was we needed our own network. And we built this network. It's a foundation, a nonprofit. It's called IPDB, Interplanetary Database. It is essentially a common database substrate for the world. We have some of the leading organizations who are charged with protecting our internet, like the Internet Archive, who have joined on to make this foundation a success. They are all caretakers in this node. They are the ones who can reach consensus. And this is how each one of you can start interacting with blockchain technology. The goal is to make it so that you don't need to understand about BigchainDB. You don't need to understand about the core unless it's actually fundamental to your kind of business and such like that. What you want to do is, as Kent had shown, there are hundreds of different use cases within blockchain that need to be experimented with. We need to start combining all these ideas and trying it. This allows people to create whatever they want in a blockchain world and start building proof of concepts in a very easy way. So I would encourage you to go to ipdb.foundation and sign up for the wait list. We already have our testnet up. We have over 60 organizations. We just opened it up on last Friday. 60 organizations have signed up. Be happy to have, what I noticed here in Scotland and from my conversations is that people are very, there's a lot of data analytics skill sets in here, AI skill, and banking. And so if you sign up, we can let you on. You can start building your proof of concepts, and that will help you. On the other side, if you want to have a little more hand-holding, we're available for consulting, ideation, workshops, and helping you through this process to learn about blockchains and get started. I think it's a great opportunity for Scotland. Somebody was asking me, where does Scotland fit into all of this? And I think that there's an opportunity for Scotland in potentially government services, health services, data analytics. These are areas that the world hasn't figured out yet. There's a couple of bright spots in Estonia and down in London in terms of government services, but those three areas that I just spoke about is somewhere where Scotland could take a lead. And one of the interesting things about blockchain is that the innovation that happened on the internet happened in Silicon Valley. It was centered in San Francisco. With blockchain, it's all over the world. We are on a race around the world to find new business models, and it's not going to be in San Francisco this time. It's going to be in New York, it's going to be in London, but nobody says that it doesn't have to be also in Edinburgh and the rest of Scotland. So thank you. Have a great day.